Okay, 6.4. Properties of quadratic functions. Remember, a quadratic function is anything that has a power of 2. So as soon as you have an x squared somewhere in there, you know you're going to have a quadratic, which is going to have a basic shape like so, or like so. As I've said before, this is a negative, it's a frown, and this is a positive, it's a happy smile. So when you see a parabola that's going up, like a swing set, okay, or a pendulum, that is a positive parabola. If you see one going, like throwing something up in the air and coming back down, that's over here, that's your negative parabola. Now, this point here and this point here is called your vertex. And the vertex is either the highest or lowest point on the path, on the parabola. So if you think about the idea of a swing set, when you walk up to a playground, the place where the seat is just sitting right there, hanging, that's its lowest point. If you get on and swing up and swing back, every time you're right here, before you go back up, the swing seat is at the lowest point in its travel. Over here, if you are over here and throw a rock up in the air, there's going to be a point where it's not climbing anymore, but it's not falling. It's the highest point. It's the most upward point before it falls back down to earth. And that's what the vertex is. Now, the vertex is a very simple formula. Now remember, it's always going to be x, comma, y. And if you think about the path of a parabola, let's say again you throw a rock up in the air. And if you were looking on this on a graph, and down here we have time, and over here we have height. As time goes on, 1 second, 2 seconds, 3 seconds, and so forth, as time goes on, the height is changing. So height is increasing as it goes through time, and at some point here, according to this picture, around 3 seconds, it's going to stop climbing and start to fall back down to earth and eventually hit the ground over here. So x, your x-axis down here, is going to represent the horizontal, and y is the vertical. So if we went over here so many seconds and went straight up, that's your y. So here's my x and here's my y. That's going to be important to think about when we do this formula, because the formula for the vertex is the x coordinate is the opposite of b over 2a. Now you may say, well, where are these a's and b's coming from? Well, anytime you have an equation, such as is in the book, you have f of x, which just means function of x. It's the same thing as y. F of x equals x squared minus 3x plus 1. Well, we don't write the number here, but the number 1 could be here. That's our a. Negative 3 is our b, and this number here, the constant with no variable, is our c. So that's where we get the a and the b from in this formula right here. So it's very simple. All we do is we take these numbers and we're going to plug them in. So x is equal to the opposite of b, and don't think that means negative 3, because b is negative 3. So the opposite of that is going to end up being positive, over 2 times a, which is, in this case, 1. So the opposite of negative 3 is 3. 2 times 1 is 2. that means 1.5. The vertex of this equation, x squared minus 3x plus 1, is 1.5. Now, when we plug this back in to this original equation, we have to go f of x equals 1.5 squared minus 3 times 1.5 plus 1. Well, what does that give us? Well, 1.5 squared, just use your calculator, is 2.25 minus 3 times 1.5, which is 4.5, plus 1. So 2.25 minus 4.5 plus 1 equals negative 1.25. So what that's telling us is that the vertex of this parabola right here is at 1.5 for x, negative 1.25 for y. So, if you have your graphing calculator, go ahead and get it out. And let's turn it on and see how to graph using graphing calculator. So you turn it on, you come up to y equals. If there's anything in there, you hit clear, just clear it out. And we're going to put in, this is our x right here. This is how we make it squared. And we're going to do minus 3x plus 1. And we're going to hit graph. And notice, right about there, here's 1, here's 2, that's 1.5. It's right in between. And notice it's a little bit past 1. It's hard to see on this small screen, but that's negative 1.25, as we reviewed in 6.1 on how to graph points. This is 1.5, negative 1.25. That's the lowest point on this parabola. And so that matches up. Now, a nice thing about these graphing calculators is, notice how the word table is here. You can hit second graph, and it will give you a table of all the points on there. So if you wanted to graph, remember in the earlier chapter we had to make a graph and make a table and test points and fill them out. This is a nice way, once you already learn the skill, to use the calculator to your advantage and find all the points on the line or the quadratic or whatever you're working with. Okay, and you just up and down arrow, and you can find a few points, and that would help you graph it really quickly. So let's say back what we were doing in chapter 1, section 1, if we had just had a line such as 2/5 x plus 3. Whoops, sorry about that, not sure what happened. 2/5 x plus 3. Now I want to graph that. Well, it's going through y right here at 3. It has a slope of up to right 5 or down to left 5. But if we didn't want to make the table and to graph it, we could use this. So notice you can even use the non-decimal ones. So negative 5.1, 0.3, and 5.5. And that would be enough to connect the dots and get a nice straight line. So that's a really good way to use your graphing calculator to your advantage once you understand the basic skills. Okay, so moving on. We have the idea of the vertex, okay, and that's how to find it using the calculation. Now, once you practice it, and you do need to know how to do this, it's a very simple formula, but once you have practiced that, on your graphing calculator, if you hit the program button, this one's kind of messed up, it's an online one, but there should be a program called Vertex. You just arrow down to it and hit enter, and if it isn't, I'll put it on your calculator in class. But you just hit enter again and it says enter A. Well, what did we say A was? We said it was 1, and you hit enter. Now you gotta be careful here. It says -3, right? We don't want to use this button here. We want to use this gray negative key, otherwise we'll get an error. Enter, and then 1. Now I have programmed mine here. Yours is a little bit different in class, but I've noticed that I programmed it to do it in fraction and decimal form. So 3/2, what we got originally, which is 1.5, and -5/4, which is -1.25. So I have it set up here, and I can modify your calculators in class to look like this. So you can always get it in fraction and decimal form depending on what's easier for what you're doing. But once you're comfortable with using the formula, I have no problem with you using the calculator to find the vertex a little bit quicker. Okay. Now moving on, if you look at the next section of the book, it's looking at the x-intercepts of parabolas. Now, if you remember in the previous section, we did x and y intercepts, and we're going to use the same concept here, but we're going to use it on a parabola. Okay, so if we're looking again at a graph, and we look at a parabola, once again, this is a negative parabola. Right here, it's crossing over the x-axis. So if you think back about what we learned earlier in the chapter when we talked about x and y intercepts, here's an x-intercept, there's a y-intercept. Same thing, but with a parabola, we have a possibility of different situations. So let's see what they could be. With a parabola, you have the possibility of 2 x-intercepts, like so. You have the possibility of 1 x-intercept, where the parabola comes up and just barely hits the x-axis before coming down, or same thing from the top, just kisses the x-axis on its way back up. And then you have the third choice, where it never actually touches the x-axis, and therefore there are no x-intercepts. Now there is a formula to find these numbers, okay? And if you look on page 367 of your book, this is the formula. There's a nifty little song to go with it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And once again, as we talked about earlier, let's say we go back to the one we used earlier, x squared minus 3x plus 1. Again, a we said was 1, b was -3, and c was 1. Now remember, with the vertex, we only needed a and b. But for this equation, we need all the letters. There's b, b again, a, c, and a again. And we plug these in. Now, it's not a very hard formula, so I'm going to do it with this first one just to show you how simple it is. So x equals the opposite of b, again, just like we did in the other one, plus or minus the square root of -3 squared minus 4 times 1 times c, 1, all of that over 2 times 1. Okay, so the opposite of -3 is +3, plus or minus square root, 3 squared is 9, minus 4 times 1 times 4, again, all over 2. That's 3 plus or minus the square root of 9 minus 4, which is 5, over 2. And you just take your calculator and you can find out the square root of 5 quite simply and use an estimate. So the square root of 5 is, sorry, hold on. about 2.24. Okay? So basically, you're going to break this up into two separate problems. 3 plus 2.24 divided by 2, and 3 minus 2.24 divided by 2. And then you just crunch those. So 3 plus 2.24 is 5.24. And then you're just going to divide by 2. And you get about 2.62. And then 3 minus 2.4, 2.24, sorry, divided by 2, and you get about 0.38. That means this parabola, which we looked at earlier and graphed, is going to hit the x-axis at around 2.6 and 0.38, almost 4/10. Okay? And if we looked at it on there on the graph, that would kind of make sense. So let's enter this again real quickly, just for practice. X squared minus 3x plus 1. And graph it. And you can see that it hits just between 0 and 1, pretty close to 0, and pretty close to 3. So that makes absolute sense. But now, again, if you noticed earlier, there was a quad program. So let's see how nice this is. You hit enter again, and it says enter A. So 1, enter. The gray negative key, 3, 1, and there you are. 2.61 and 0.381. Now this formula has both because the roots came out as decimals on both of them, but that's okay. But I just wanted to show you that this is another way you can use your graphing calculator, after you understand the concept of the formula, to go ahead and find the x-intercepts of parabolas. Now one more quick thing here about these. Sorry, my dogs are playing a little noisy. So, just so you know, recognize the vocabulary, we've been saying x-intercepts. But if you notice, the calculator said the roots are. And the book even refers to solutions. These are all the same term. The x-intercepts are the roots of the parabola, which are the solutions of the equation. So just so you understand that those are all interchangeable terms. Now you will have some word problems in here where you want to look for keywords. If you ever see the words maximum or minimum, you automatically know you're doing a vertex problem. So look for those. If it's asking you the maximum height, you know you're doing a vertex problem. Or if it asks you about the least number of something, you're looking for the vertex. Now it may ask you just for part of the vertex, like it may just ask you how many days or how many seconds, and that's just the first number, the x-coordinate. So think about it. If you're looking on a real world problem and it's going up in the air, like we had before, 1, 2, 3, 4, and it looks like the vertex is about 2.5, and if it said how many seconds until it reaches the vertex, you would not put 2.5 comma whatever it is 8. That's not the answer. If it says what is the vertex, there you go. If it says what is the maximum height, you just use this number, 8 feet, 8 inches, whatever. If it asks you the time when it hits the height, you're just going to say 2.5. And always use words, always use a label, like 2.5 minutes, 2.5 seconds, and so forth. Okay? And if you notice, the next part of your instructions say to just use the quad program on those few problems, make sure you do that using the calculator. There you go.